All right, you got a lesson up here, 7.5, properties of logarithms. Like I said, this is where this gets a little more challenging in comparison to the other 3 lessons we've done so far. But at its core, you're trying to get it down to the 2 types of problems we had in 7.4. Okay? You're trying to get it down to where you have a log, let's say a base of 2 to 3x equals 5. All right? Trying to get it down to where you have 1 log on one side, and then you what? Starts on S. Nope. Switch. Switch it. Okay. Or or where you have logs on both sides, and then you just drop log and set equal. Okay. That's what we're going to try to get these problems today too, except now there's going to be multiple logs on one or both sides of your equations. Okay? Don't worry about it. Sure. Okay, Ms. Dixon?
Will you ever have a problem that's like log 2x plus that equals log 3?
No. Logs will, no, logs will always be the same. Or the base as well. Alright? Yeah, 100%. Okay. That's what we're trying to do today. You're going to be given multiple logs on either side, and we need to combine them. And the combining of them is what is new and different. Okay? So, the book starts with this little explanation. It's decent. It's not great. It starts with this. Because logarithms are exponents, right? We talked about that. When you put a log and it spits out, you get an exponent. All right, Sam? Yeah. Since a log is an exponent, their properties come from the properties of exponents. Okay? Like if you're multiplying bases, you add your exponents. Dividing, you subtract. Power of a power, you multiply. Stuff like that, right? So there are some similarities. You will see some similarities to them, but they're not like identical. Okay? So, the first one, and we're going to learn 3. All right, we're going to learn 3. If you write something, definitely write the symbols on this one. Okay? Write the symbols, it helps. Okay, for all positive numbers a, b, and x, where x is not 1. Okay? So, for a log base x of the quantity a times b, so basically the log base x of, like, say, 3b. Okay? You can rewrite that as log base x of a plus log base x of b. Okay, so so let's say, like I said, you have log base x of 3b. You can rewrite that as log base x of 3 plus log base x of b.
What if it is 1?
If it is what?
What if it...
All right, now, what operation, let's make sure we get clear on this, what operation is going on between this 3 and b?
Multiplication.
Multiplication. Okay, so if you have a multiplication of 2 objects, 2 things, a 3 and a b here, you can split them off as a sum of 2 separate logs with the same base. Okay, see that? All right, now, any good rule and any good equation means it's got a 2-way street, right? So not only can you go from here to this way, more often you're going to go from this way to this. Okay? And that's the issue. You have to change, you have to learn these properties, because I'll see a lot of times that people see this, they know they need to combine them. They know that. They know they need to get down to 1 log, but instead of putting 3b, they just put 3 plus b. Okay? I see it all the time. See it every year. you multiply those quantities together. That's how you combine them properly. Okay? So if you're given two logs with a plus in the middle, you rewrite them as one log, multiplying the quantities you're taking logarithms of. Okay? Here are the other two. Okay? The other two, if you can kind of look at the names and figure out that they're pretty similar. The second one is the quotient property of logarithms. If you look down here at the example, for all positive numbers a, b, and x, where x does not equal 1, all the normal lingo that they have to say, log base x of a over b, it's a division, so the operation in between them is going to be what? Subtraction, right? Just how it was with the other one, right? The operation between the two is multiplication, or between the two is addition, so when you put them together, it was multiplication. The operation between these two is subtraction, so when you put them together, it's going to be division. Chamberlain, go ahead.
Okay, so you know how division and subtracting, you'll be making the number smaller, right?
Right.
So would that would be like if you had a add and a multiplication, like do they what I'm talking about?
No.
Subtraction and division, like so you see a subtracting, you gonna divide.
Yes.
You see a addition, you gonna multiply.
Yes.
Like,
Right. Just like you're right. Right. All right. Okay. Just like if you look at the example in that box, if you have log base 2 of 5 minus log base 2 of 6, you can go backwards according to this example and make it log base 2 of 5, 6. Okay. One of the keys here is to make sure you do the first one over the second one. Okay? The first subtraction, the subtraction that's on the left, the term on the left goes in the numerator. The term on the right goes in the denominator. Everybody see that? Okay. Any questions on quotient? Pretty similar to product. It is, yeah. Okay. Quotient and product are pretty much the same way. Everybody good? Okay, the one that is the different one is the power property of logarithms, okay? And look, if you look right here. The same old jargon for any real numbers, p, and positive numbers, m and b, where b does not equal 1. Log base b of m to the p power. So you have a log to a base of a quantity with a power on it. Okay, everybody see that? I know it's a little small up there, but you got slides up too. Okay. What you're able to do is take that power that is on the quantity you are taking the log of and bring it down in front. See that? Okay. So if you look at the example, log base 2 of 6 to the 5th, what you are able to do is bring that 5 down in front and rewrite it that way. 5 times log base 2 of 6. They're equivalent statements. Just like the rest of them, you're also able to go the other way. You're able to bring a number that's in front of the log and move it up to the exponent of the quantity. Okay. All right, so solve. 2 log base 7 of x equals log base 7 of 27 plus log base 7 of 3. That's what it says. 2 log base 7 of x equals log base 7 of 27 plus log base 7 of 3. All right, now, the first thing you should do is note to yourself how many sides of your equations have logarithms to them. Okay? Not how many logs there are. Hold up. How many sides of your equations are there logs on? 2. Okay? So we need to get each side down to having 1 log. Okay? And that log cannot have anything in front of it. All right? So, Chamberlain. Nope. Nope. Yes. No. And that's the issue, okay? That's the issue. You cannot, the log prop, here, hold up. Let me show you this, okay? Log base 7 of x plus 3 equals log base 7 of 2x plus 5. Remember this? Okay? Logs on both sides of the equation, same bases. You cancel out the logs and you set the quantities equal to one another, right? That property in 7.4 that we skipped over real quick only works if it's one log on each side and there's nothing in front of it. Okay? All right. Ease.
Got a question.
What up?
If you combine like terms, do that base number change?
No,
It doesn't change?
does not. Okay?
So you just add it?
No, Dylan.
You take the 2 and you make it.
Good. We're going to take that 2 that's in front. Take this 2 and move it up here. Because remember, like I just said, these have to be strictly nothing in front of your logs. Okay, so log base 7 of x squared. Now, these 2 logs are being what?
Multiply.
These 2 logs are being added. Now, whenever you are combining 2 logs that are being added, what do you do with the quantities?
Multiply.
You multiply. That's what we just learned. Okay? So you rewrite those 2 logs as log base 7 of 27 times 3, which gives you 81. Okay, now that you have it down to a log on each side with nothing in front of either log, you can do what you did in 7.4, which is drop your log. So now you have it down to x squared equals 81. Okay? You take the square root of both sides to solve it, right? Okay, so square root this side, square root this side. So x equals, hold up, when you take a square root, you put in what? Plus or minus. Alright, don't forget about that. Okay? Because sometimes it'll matter. Okay? Sometimes it'll matter. In this case, though, it won't. Why not? Nope.
Because it's a log. Oh, and you trying to find it equal to n.
Because when you plug it in, when you plug that -9 in there, what's it do? No. What's log base 7 of -9?
It's 81. So negative will never work.
So, nah, it's from last lesson. In this one, yeah, negative will never work in there. But what if it's a quantity that makes it positive? Just like last time, just like 7.4.
So if it's like squared, like if it's like r x squared and then
Okay. So your only answer is 9. Okay, now, same process. You have logs on how many sides of your equations? 2. Okay, so log base 6 of 0.1 plus 2 log base 6 of x equals log base 6 of 2 plus log base 6 of 5. First thing you have to do is go through and move your exponents up. Okay, that's always first. So if there's any numbers in front of logs, you have to move them up to exponents first. So the first thing we have to do here is turn this to log base 6 of x into log base 6 of x squared. Okay, that's got to be first every time.
Will always be a 2.
No. All right, everybody good. Now you have two sums of logs on either side. How do you put those together? You multiply. Okay, multiply the quantities. So log base 6 of 0.1 x squared equals log base 6 of 10. All time. That's not what I did. Now that you got down to logs on both sides, now you can what? Drop them. Get 0.1 x squared equals 10. Next step is divide by 0.1. So x squared equals 100. Right? Okay. Square root both sides. X equals. Okay. Plus or minus 10. Go in, check, see how they have this x here. So which one's going to work? Just the plus. X equals 10. Nothing in front, so you have to move nothing up. Okay. What's the new part here?
You gotta get the same base.
You got no, there should be. Okay. That was a typo. Okay. You got your first subtraction. Okay. Which means we have a division. All right. Now, here is where knowing how to work your calculator comes in handy. All right. Because you have to divide 64 by what? Not negative 8/3. Just 8/3. Okay? You have to know how to do 64 divided by the fraction 8/3.
Once you put 64 over 1, then you...
Okay. Or, like Lydia said, when you divide fractions, you just multiply times the reciprocal. 8 goes into 64 how many times? 8. 8 times 3? 24. So log base 7 of 24 plus log base 7 of 2 equals log base 7 of 4x. Now you turn it into a plus between two logs. Okay, so that's how you handle that. You do your first one, get it combined, now do the next two. So now you do what?
Multiply.
You multiply, so 24 times 2 gives you? 48. So log base 7 of 48 equals log base 7 of 4x. Base is the same, nothing in front. You can drop log. 48 equals 4x. Divide by 4, x equals 12. So, you got the plus in the middle, right? Which means what? Multiply. Multiply your quantities. So I'm going to show a lot of work here, okay? So log base 6 of x times x minus 9 equals 2. Okay. Now, I said something very early on that the first thing you should always do is what? The first thing you should do in every problem is what? See how many logs you have on either side of your equations. Okay. So how many sides of your equations are there logs in this one? One. There's one side of the equation with logs. There's two logs on that side, but there's one side with logs. See that? Which means eventually we are going to do what? Switch them. Switch forms. Go from logarithmic to exponential. All right. Now, the first thing you have to do is put these together. Put these two logs together. Okay? You can do this after that one of two ways. You could switch it right now, make it 6 squared equals x parentheses x minus 9. Or honestly, what I do, I distribute first. Okay? I go log base 6 of the whole quantity, x squared minus 9x, bless you, equals 2. Reason I do that is so that way I know the quantity that I'm switching to the right side. Okay? Make sense?
Oh, you still keep it in parentheses?
I do, yeah. Just so I know what all goes. Okay? As long as you know what all goes to the right side, it's unnecessary. But to make sure I know what all goes to the right side, I put it all in parentheses. Okay? Make sense? Now you switch. So it becomes 6 squared equals x squared minus 9x. Switch forms. 6 squared is 36. What kind of equation you got? Start to the Q. Quadratic, so it's got to equal 0. So I'm going to subtract 36. 0 equals x squared minus 9x minus 36. Yeah, that's fine. As long as your x squared's positive. Okay, so now I'm going to take my 0 equals 0 from my left, put it to my right, like that. No harm, no foul, right? Okay, still equals 0. And then what do I do? Factor it, good.
Why not 12 and 3?
X minus 12, x plus 3. Okay, hold tight, hold tight, hold tight, hold tight. Split them off, solve them, so they switch to what? X equals positive 12, x equals negative 3. Which one do you throw out?
Negative.
Throw out negative 3, circle 12.